Chapter 11, Section 1, Rock Deformation. Deformation factors that influence the strength of a rock and how it changes include temperature, confining pressure, rock type, and time. But before we jump into what those things can do, what exactly is deformation? Deformation is considered to be any change in the original shape and or size of a rock body. All of your crustal deformation is going to occur along a plate margin, so at a divergent or a convergent plate boundary. And that deformation can happen in several ways. You have stress, which is a force per unit area acting on a solid. You have strain, which is the change in shape or volume because of stress. So it can change in brittle deformation or ductile deformation. And we'll take a look at both of those in just a minute. But we also have other types of deformation. So deformation can also occur from temperature and pressure. If deformation does occur by temperature and pressure, it is a permanent change. So that means it can never go back to what it once was. It cannot be reversed in any way, shape, or form. So brittle deformation is a fracturing, so when strength is exceeding, so you're going to have a lot of jagged pieces, whereas ductile is going to be more of a flowing, more of a bent type, so there's not going to be any fracturing. The rock type is very important, so what it's made of and the texture it has is going to affect how it deforms. And time, of course, will affect it because time, with anything, nothing is going to happen immediately or instantly. So it takes a period of time, quite a long period of time, for a rock to actually be changed because of deformation. And it actually takes even longer for it to really be shown. There are three different types of stress. There's tensional stress, compressional stress, or shear stress. Just like their terms, compressional is when you compress or push it in, so it's got that bending look to it. Tensional, just like with a rubber band, you stretch that out until it fractures. And then shear stress, when we talked about earthquakes, you saw the elastic rebound hypothesis. So you have two different directions being pushed, and it will eventually shear or break off and cause those rocks to deform. We also have folds. So we have anticlines and synclines. The anticline is the upfolding or an arch. So you can see that here. A syncline is the opposite. It's a downfold, and it's often found with anticlines right nearby. And it kind of makes this bowl shape here. So again, anticlines and synclines go together. So where you find one, you will find the other. And you might have an over amount of stress, of compressional stress, that causes an overfolding. So it causes this to happen here, where it kind of looks over bent instead of an anticline or a regular syncline. We also have what's known as monoclines. So instead of moving in a bent shape, it's more like a step. So it's being pushed up and pushed down simultaneously. You can see that here. And then we also have faults, and there are four different types of faults. We have normal faults. So you have what's called a hanging wall that moves down relative to a footwall. So for example here, and you can barely see the arrows, but here is the footwall. That would be the wall that you could stand on, is moving upwards. The hanging wall, that's something you could hang things from, is moving downwards. We also have reverse faults, so it's the exact opposite. The hanging wall would move up, and the footwall would move down. You can see that in the image down at the bottom. The other two types of faults that we have are thrust faults. It's a reverse fault, so it's still hanging wall moves up, but the dip is less than 45 degrees. So it's a very, very shallow angle. And then we have what's known as strike slip. And this is where the movement is occurring horizontal and parallel to your trend. So this is a horizontal movement instead of an up and down movement. And you can see that in the image at the bottom. So the 4 types of faults, just to recap, we have normal, hanging wall moves down; reverse, hanging wall moves up; thrust fault. Okay, your hanging wall moves up, but look at the angle here. This is a very small angle in comparison to this. It's a very small angle for thrust fault. And then strike slip, moving back and forth. You will also have joints. It's a fracture where you have no significant movement. So you'll have lots of jagged pieces like this image here and here. So today, go ahead and read 11.1 in the Earth Science book. You will do a rock deformation handout, and that's it.